What's up people, and welcome to my tutorial in Pragmatic Data Science. So in the previous video we had a look at the theoretical approach of how you would go about and implementing something like this, right? Where you would have I usually think of it like this, like a mixer board here where you have, in this case, instruments, so like saxophone, voice, bass, guitar, whatever, and then you have these like sliders or knob that you can, adjust back and forth, and I'm pretty sure that you have seen this kind of layout before. And so that's the intuition. And also the intuition here is that you can very easily add another slider or knob if you like. Like you can have arbitrarily large mixer board if you like. Like you can also do this appending and removing of sliders during runtime if you like. And I'm going to show you what that is, how you can do that real easily. So what I have done here, I'm like a TV chef, I've done some preparations beforehand, right? So here is my mixer board right here called the weights. And the length of this one here is the exact same length as number of columns that I have in my data set here, right? And in the previous video, in the theoretical approach of this, what I did basically, I said that you can take this right here, which is this is one slider, this is one slider, this is another slider, and you can just add them here arbitrarily large. What you would have like a new constant here, of course, like d, and then x4, etc., and then you would have x5 and e here, and you can keep on appending these either during runtime or statically crunched offline or whatever. It doesn't really matter. But there is one really easy thing that you can do. Like if you set one of these constants values to be equal to 0, you can effectively see what this is going to do with the output, right, with the score. So if you set any of these constants to 0, it's going to multiply the existing value coming from your dataset with 0, and that is going to mean actually an output of 0, right? So it's going to look like this for all the ways that have a 0 in there. So it's going to disable them basically. So if you do that, it's going to have the exact same effect as if it was not there. And architecturally speaking, when you implement this, it's much easier to just have all your features there and then just disable them by setting them to 0. And that is what I have done here in my weights, in my mixer board weights array here. And what I've done also is I have taken the data set from previously. It's the exact same data set, and this is exactly the same thing. I've defined a couple of parsers that is going to take the input value and parse it to a floating point between 0 and 1. No, sorry, actually it's not going to do that. It's going to just parse them back to integers and floating points. And if you look at this, so like here I parse a boolean. So if I get, you remember from the data set here, all the boolean variables are defined as yes or no here, which unfortunately we cannot use in the data because multiplication and stuff only knows about integers and floating points and numbers, right? So if it is a yes, we return 1, otherwise we return 0. So we're just parsing it to 1 or 0, whether it's yes or no. And yeah, we also have this for floats, where you just parse it to a float, because when I read it on the CSV file, it's going to be inputted as a string, so we just need to parse it to a floating point. And the date we need to parse as well, because it has this year, month, date format here that we need to cast it to a timestamp. And we are not actually going to use the date, even though you can do that, of course. But the date is kind of an edge case. Don't focus too much on that if it confuses you. And the same thing goes for integers. So now I have this parser functions that I can use. And basically what I've done is defined this thing right here, saying that it is a mapping between a text string and a parser. So it's a dictionary here. So like the date is going to use the parse date function. The temperature min is going to use the parse float because it's a floating point. And I had to do this manually and check these values. Okay, this is a floating point, floating point, floating point, date. The bearing is an integer. And this is floating point, Boolean, and yeah, the rest over there is Boolean basically. So that was the first thing that I had to do, define all these parsing from a column to a parser. And then I define the weights. I read in the data as I previously also did. And here I actually consume the parser. So I iterate over each row in the dataset. And for each row, I check if each column in the row is actually contains anything, because there is some dirty data in the dataset where some of the columns are empty. So this is just the sanity check for checking if there's actually data on that row. And then I use this parse dict right here. And then remember I have this header array, which is just the array of text strings that is going to contain all the column names. Actually, I think I'm gonna write that out so that is obvious how that actually looks, and I'm gonna comment everything else out just so that I will not confuse you guys. And I'll run the data, and it's gonna take a while to run, but there you go. So I have all the column names in this array called headers. I hope you can see it because of the transparency. Alright, so that is what header is gonna do for you. And also I suggest you, of course, like take a look at this in your own time, and also like pause the video, but yeah, clone the repository, of course. So here's my headers, and then I use this parse dict with the column name. So this is gonna be, for example, like this date. So it can map them between the header names and this parse dict, and there it's going to figure out which one of these parsers is going to have. So maybe like a parse float, and then it's just going to call that with the parentheses here and parse in the column value here, which is then going to go to each individual parser. So like here it's going to parse Boolean, floating, you can see the values is going to come in there, right? So that is just for a little bit of like to be a little bit dynamic. And then here comes the interesting part, because in the previous videos we actually implemented the normalization of the data. And I mean, that is fine for all practical reasons, but there is one thing that you have to be aware of when you use Python, and it's that it is a script language. And there is this really common interface called, library called NumPy, which is really great. It has implementations of arrays, so you can use sparsity and stuff like that. And it is also, if I am not wrong, I think the core of NumPy is actually implemented in C++. So basically the takeaway from that is that if you use NumPy arrays instead of ordinary arrays, Python arrays, that is going to be much faster. And that becomes really important when you have bigger data sets later, especially sparsity when you're working with real machine learning data sets. And another really nice thing that it comes with is this normalize function, because this is not the normalize function that I had previously. I removed that function. So this normalize function is coming from something called sklearn, which is short for scikit-learn, for science, machine learning, something, I think, and from the pre-processing library there. And this scikit-learn library, I suggest you also head over to the site and check out the documentation and everything, because this has some really nice features implemented in it, especially this normalized data, which is going to do the exact same thing as we did previously. And here I just specify that it's going to be on the 0 axis here, so it's going to be from like the bottom, from the top to the bottom instead of this direction. So if you remember the structure of the data set here is going to be nested like this, where the dimension axis 0 is basically, if you have some data in here, maybe you have some other data here. When I do axis 0, it's going to say, okay, sum up this, this, and this, and then normalize that. So that is what that is saying. And also use the normalizer that you should be using is the max value that it's exactly the same thing that we implemented before. So at this point, this data should be normalized. And also one really nice feature is that you remember this data variable here is pretty big. And the nice thing with like when you use NumPy arrays is that, yeah, by the way, even though this normalized function is coming from scikit-learn, it is going to return a NumPy array. Side note. And one really nice feature here is that if you actually print one of these variables out in the terminal, it is not going to blow up your terminal with extreme amount of data, but what it's going to do is going to structure it for you really nice. You can actually peek into that structure and see how it actually looks, right? And as you can see here, it has this like dot 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 thingy where it's abbreviated it. It took the first couple of rows. Oh, sorry. Took the first couple of rows there and printed them out, and you can see these are all decimal values here from between 0 and 1, and where a lot of them are actually 0. So that is what the data variable looks at this point. And as I said, like clone the repository and go through this all yourself so it makes sense to you. And then what I do here is I iterate over the data from the dataset. I have a score, and then I call this function, which I'm going to take a look at in a while. And then I just calculate I do this multiplication here, where I multiply the weights here, and I multiply the rows. And then I do that for all the columns in the dataset. Basically what I'm doing here is this part. This actually multiplication here, multiply with the x values, next content with x2, and so on. So in this case, the x values is coming from this row I column, and the weights is my constants that's hard-coded up here. And then I'm just going to check if the score is better than the best score that I have so far, and then I'm just going to save it. And then I'm going to check what date that was actually happening. Just for me to be able to find it in the CSV file later. So I do that for the best score and the worst score. And then this is just for grabbing the current date when I iterate it. And then I print it out here on the bottom. So let's take a look at this reverse row here, because this is interesting. Because if we look at this function right here. So if we take a look at the data set, right? If we start with oh, it's a bit laggy, sorry. My Excel version is the worst on my Mac. I don't know why it is so. I think it's gonna read in everything in memory. But yeah, whatever. So here, if you remember how the temperature works and how that is going to affect the score variable. So a big score, let's say that you would have a perfect score of 1.0. That means that when you multiply that with 10 later, so 10 persons, you're going to bring in all the cavalry, right? You're going to take everything that you have because it was a very high temperature. And now if you instead think of a low temperature, what that is going to do to when you multiply a low variable to 10, that is going to bring in something that is less than 10, right? It can never be more than 10, as long as all the weights sum up to 1. So now if we think of something else, for example, if we think of, let's take the average wind speed. So the rationale behind this is that when it is windy, when it is blowing a lot, you will have a high number here. Like, for example, this day was pretty windy and this day was pretty windy. And a high value in this column is that is gonna bring up your score, basically, which is gonna be kind of the opposite of what we're looking for, right? So a high wind temperature means that you should get a low score. So you need to reverse it, basically, what I'm trying to say here. So remember also, like at this point, when we call this reverse row function here, we have normalized all of these rows. So we have all of these values as floating points. So basically it's really straightforward. All you have to do in order to reverse it is to take 1 minus and then the actual values. Now it's going to be reversed instead. And that is going to do, so now when you multiply it, if you have a windy day like this one here, let's say that when you have normalized this, it's 0.9 in windiness. So now when you take 1 minus 0.9, now you get instead a score of 0.1 when you have reversed it, which means that when you multiply that with 10, you're going to get a lower score. I hope that makes sense to you. So basically what I'm saying is that for the columns that a high value is going to mean, should mean at least a bad score, we need to reverse them. And that is true for almost all of the columns here. For example, a high wind speed means that you should get a low score. And if it is foggy, you should also get a low score. And that goes for basically every column here except for temperature, I think. And sometimes it doesn't make sense. For example, a bearing here doesn't mean anything because, you know, we can't even use the bearing. Like, yeah, it's blowing, the wind is blowing from north. Is that a bad ice cream day? I don't know, maybe. But in this case, I assume that it doesn't matter at all. So that is what I'm doing here. So I manually implemented what columns here should be reversed. And now at this point, I should have a matrix that looks like this that we peeked into previously, where a high number means something that is going to bring in more people, and the low number means that you're going to bring in less people. Right. And then I just calculate score. So let's take a look at that, what that gives us. So what I've done right here is I've put 30% weight on precipitation, basically if it was raining or snowing or whatever, and also, no, sorry, on temperature min and temperature max. Here I don't have to take the average anymore because I'm using both of them anyway. So I'd use min and max values. And then also the reversed value here with the precipitation. So it was windy or not. And I put 20% on that. And then also I use this one here, which is if it was foggy. So if it was foggy, I should get a bad score, basically, because that is not ice cream friendly. All right, so let's test this bad boy out and see what it gives us. What it's going to do basically is just going to calculate the best and the worst day. Oh, sorry, I forgot to save the file. I do that all the time. All right, here we go. So, all right, so the worst day had a score of 30%, and it was this state right here, and the best score had a 99% score, and it was on this state here. So let's take a look at what this data looks like in the CSV file here if we search for them. So this was the bad day that I searched for now. So this was the 0.32 day. And as you can see here, the wind, it was pretty bad. These two are the min and max values. And it was really cold this day. And also there was a little bit of precipitation going on. And it was also foggy here. So, I mean, this day, wow, it was really bad weather. So, no ice cream for you. And what about the other day, which was in 2010? So this was a good day. And here you can see that the temperature was really high. It was, the average was about 91. And there was no rain or snow or anything, and it was not foggy, so this was an ice cream friendly day, right? But you know, why stop there? We have disabled everything else here. We don't consider, for example, windiness and whatever. So you can see, for example, on this particular day here, this is the average wind speed column, and if you compare the temperature on this day with the previous day, you can see they're almost the same temperature, and I would say that for all practical reasons they are pretty much the same temperature in terms of ice cream, at least. But it was more than twice as windy this day than the previous day. And so let's see what happens when we also put that into equation and say that, you know what, we're gonna also take into wind into consideration. So let's see what that column is. This is this, so it's the sixth index. So it's like 0, 1, 2, 3, 4, 5, 6 is this one. Let's say that we put 20% weight on that. We need to redistribute a little bit here, so I'm gonna take out the fogginess and the precipitation a little bit lower, and now it's like this sums up to 6, 7, 8, 9, 10, right? So it's 100% right there. And now we test it out again and see what happens. Alright, yeah, so we got some other day here that got some other score, but it was pretty similar. But it was another date. And the best score was, I mean, a bit lower here, so 93%. And it was also on another day. So let's check out what happened now if we peek into the data here and search for this. So it's on this day right here. You can see, wow, oh yeah, this was a really bad day, and it was rainy, and it was, I mean, it was really bad. It was windy as well, and it was foggy, and yeah, I would say that intuitively I would feel that this is worse because the other day, sure, it was raining and stuff, but you know, here it is pretty windy as well. That's gonna make it so much worse. And also, I don't understand how it can be both this windy and foggy, but yeah, this is the data. And it was really cold as well. And what about the good day? It was some other day on 2011. Yeah, it was something that had very similar temperatures to the one that we looked at previously. And yeah, no rain, of course, and much less wind. It was almost half the wind, so probably much hotter and ice cream friendly, and no fog, of course. All right, so I hope that this gives you some ideas of different implementations that you can make. And this is a really simple tool for just modeling a problem with linear combinations. This can only model linear problems, of course, since it's a linear combination of stuff. But that doesn't mean that it is, you know, simplicity sometimes is the absolute best tool that you can use. And some of the implementations that I've seen with this is really impressive as well. And I hope you guys liked it. And if you have any questions, just leave it in the comment section below. And don't forget to subscribe. And I will see you in the next video. Bye-bye.